Now that we understand how quadratic functions work, how their graph works, we are able to now look at some applications of quadratic functions. And so first, some tips as we set this up. If we want a specific point on the graph, all we have to do is plug the number into the equation. That's pretty straightforward and basic. Now, if we want to hit the ground, quite often quadratic functions are used when we throw something maybe out of a window or off a cliff. It goes up in the air and it comes down and it hits the ground. The point where we hit the ground is the x-intercept. So if we find the x-intercept, we have found the hit the ground point of whatever we're talking about. The other key point we're often interested in is what is the highest point or what is the lowest point if it goes the other direction. The highest or lowest point is always the vertex. And we know how to find each of these points on the graph. So let's take a look at some problems. Hopefully they make a little bit more sense than Billy having 32 candy bars and he eats 28. What does he have now? Diabetes. Billy would have diabetes. Lots of candy bars. All right, here's a better example. A ball is dropped from a 135-foot wall. According to the formula, h of t is 135 minus 16t squared. We have the function. What is the height after 2.5 seconds? So that's seconds. That tells us the amount of time that's gone by. So really all we're interested in is a specific point. We just need to plug those 2.5 seconds into the time to get the height. So 135 minus 16 times 2.5 squared. And if I have a scientific calculator, I can just plug this directly into my calculator to figure out what that value point is going to be. So I'll type in 135 minus 16 times 2.5 squared. And when I do, I get a nice round 35 feet. After 2.5 seconds, that ball is 35 feet in the air. It's traveled about 100 feet. Let's look at a more interesting example, though. We have a firecracker that's fired into the air out of a window of a building. So it started up a little bit high. The height is given by this formula. So we've got a formula here to guide everything we do. It's going to be the 16t squared plus 32t plus 48. And there's two questions we're going to answer. One, when does the firecracker hit the ground? And two, what is the maximum height that firecracker reached? So first, when does it hit the ground? The ground is going to be the x-intercept. So we want the whole thing to equal 0. So 0 equals negative 16t squared plus 32t plus 48. First thing I'm going to try and do is factor it, because if I can factor it, we get an easy solution. If it doesn't factor, we'll have to use the quadratic formula, or we'll have to complete the square. First, GCF is negative 16. When I pull out the negative 16, I get t squared minus 2t minus 3. And that does factor really nicely, negative 16. T times t is the t squared. 3 times 1 can give us negative 2 if the 3 is negative and the 1 is positive. Set each factor equal to 0. T minus 3 equals 0. And t plus 1 equals 0. Add 3 to both sides, and t is equal to 3. Subtract 1 from both sides, and t is equal to negative 1. Well, it doesn't make any sense to say that negative 1 seconds, a second before it was thrown out, it's at the ground. That negative 1 is a false solution. We have to be careful of those negatives when we're talking about applications. But it would make sense to say, hey, after 3 seconds, that firecracker has been shot into the air and landed on the ground some distance away. So now we know how long that firecracker was in the air. We want to know when does it reach its maximum height. And it's not the middle point. To find the maximum height, we need the vertex. The vertex is always the peak. So let's take that equation, h of t, or h of x. oops, it should be the same variable. That's a typo. It should be h of t. H of t is equal to negative 16t squared plus 32t plus 48. To get into vertex form, we first factor out the negative 16, which leaves us with t squared minus 2t plus 48. Find that magic number using that negative 2. Negative 2 divided by 2 squared is 1 squared, or just 1. So we're going to add 1 inside the parentheses, and we'll subtract 1 from the end, but we have to multiply it by the a, by the negative 16. When we do, we got the negative 16 factored. We have t minus 1 squared. Plus negative 1 times 16 is, negative 16 is a positive 16. So 48 plus 16 is 64. And so the vertex is at the point 1, 64. H, k, but remember the h is opposite. The first value tells us the amount of time. After 1 second, we are 64 feet in the air. So what is the maximum height that reaches? The maximum height is 64 feet in the air. So with these application problems, what we're really looking for is if we want to hit the ground. That's really generally our x-intercept when the equation equals 0. And if we want to know what the maximum height is or the minimum value is, that's generally going to be the vertex, which we can get into vertex form. We've been doing that for a couple days now. So take a look at the homework assignment and see how those applications of quadratic functions work, and let your instructor know if you have any questions.